Hey everyone, welcome to Stat 254 tutorial. This is the week 6 demo. Let's jump right in. Question number 1. Suppose that x is a continuous random variable measuring the lifespan in years of a particular brand of microchip. It has the following PDF. So we say f of x is equal to 64 over x to the 5 anytime that x is greater than or equal to 2 and 0 otherwise. So this is called a piecewise function. We often see it in statistics. We've seen it before. It's asking us to find the CDF of x. Remember that CDF stands for Cumulative Distribution Function. Don't confuse that with the PDF, which stands for the Probability Density Function. Now we're talking about continuous random variables here. So there's no PMF. We only have a CDF for the cumulative or a PDF for the probability density function. And the distinction between the two is very simple. The CDF, which we denote as capital F, is the probability that x is less than or equal to some value. Whereas the PDF, denoted with a little f, is the probability that x equals some value. Now, we have to discuss quickly about, in continuous probability random variables, the probability that x exactly equals any number is 0. I've written equals here to keep the jargon simple, but just remember that the probability that it actually equals any value is 0. But we can say the probability that x is in a range around k would be the PDF, okay? For your purposes and the way you can think about it, if we're not being rigorous, we can kind of think about it like capital F, cumulative, is less than or equal to k, PDF, small f, x is equal to k. And if we want to go from small f, from the PDF, to capital F, the CDF, then we integrate, okay? So I have here that capital F of k, so the CDF, is going to be equal to all of the values that k could take on all the way up to x. So always remember, just put the little x at the top of your integral. The bottom's going to start out at negative infinity unless we know something more about the situation. Let's do the integral. We have our setup here just like we started with. Remind ourselves this is little f of x. So this is our PDF. And so we want to substitute this PDF in for f of k. And because we're calling it k, we substitute the x for that k. So now notice that I've changed the negative infinity at the bottom of the integral sign because it says that our function is 0 if x is not greater than or equal to 2. So we can just start at 2. We don't have to start all the way at negative infinity. And then all I've done is just placed our PDF from the question in here instead of the f of k. So we see in green that we had 64 over x to the 5. Because we're substituting k here as our dummy variable for integration, we have 64 over k to the 5. And of course, what I always like to do, because I get confused, is if I have a variable in the denominator, I always write it with a negative exponent. And then this is just what we've learned in the first couple years of calculus here, the first year actually. So we're going to integrate this, values from 2 all the way up to x. If you're rusty on your integrals, you should swing by the Math Help Center. They can walk you through. They're open several hours every day. Ask me during tutorials if you want specific times. But we carry on here. We have negative 16 over x to the 4 minus 16 over 2 to the 4. And if we calculate that out, we get that our answer is 1 minus 16 over x to the 4. So we saw that our PDF, stuff in green, was 64 over x to the 5. And we have that our capital F of x is 1 minus 16 over x to the 4. But whenever you're specifying a CDF or a PDF and things change at certain values, we have to type it out or write it out in a certain way. We couldn't just answer this question 1 minus 16 over x to the 4. We have to plug it back into the piecewise function. So the proper way to answer this question would be capital F of x is equal to what we just solved for, 1 minus 16 over x to the 4, for all values of x greater than or equal to 2, and 0 otherwise. All right? Hopefully that made sense. We went quickly through the integration because this course isn't on integration, but it is a prerequisite. Let's move on to question 2. All right, so question 2 is a continuation of question 1. We're still talking about the same situation. Now it says, suppose we look at the 3 microchips. What is the probability that the first chip has a lifespan of at least 3 years, the second chip has a lifespan of at least 4 years, and the third has a lifespan of at least 3.5 years? You may assume the lifespans are independent. That's our favorite word, independent. And remember, the second that you see that, it means we can take the individual probabilities and multiply them together. Like we've seen before, it's saying because of independence, the probability of A and B and C is just equal to their individual probabilities. Probability of A times probability of B times probability of C. So, we need to find those 3 individual probabilities and multiply them together. We need to find the probability that the first microchip we look at, which is why I've denoted it x1, is greater than or equal to 3. We want the probability that x2 is greater than or equal to 4, and the probability that x3 is greater than or equal to 3.5. Okay. Remember that a really great thing about continuous random variables is that the probability that x is greater than or equal to k is the exact same thing as the probability that x is greater than k. Right? Because we said a little bit ago, the probability that x absolutely equals k for continuous random variables is 0. We'll go over this a little bit more in the tutorial with an example, but just remember that for continuous random variables, when we have greater than or equal to or less than or equal to, it's the exact same thing as greater than or less than. So we don't have to worry about the stuff we did last week where we're subtracting off and figuring out where on the number line we want to start from. Continuous random variables are far easier than for discrete random variables when it comes to this. Okay, so we've got 3 individual probabilities that we're looking for. Now remember, when we say capital F of x, CDF, we're always saying that that's the probability that x is less than or equal to some value. But all of the probabilities we're looking for are asking for the probability of greater than or equal to some value. So, knowing what we just talked about, it's very simple. All we have to do is 1 minus the opposite to get what we're looking for. So the probability that x1 is greater than or equal to 3 just becomes the complement, 1 minus the probability that x is less than or equal to 3. Similar for the second one. The probability that x2 is greater than or equal to 4, we can write that as 1 minus the probability that x is less than or equal to 4. Because the formula we came up with for capital F of x gives us less than or equal to. So we always have to rework the problem to get things into less than or equal to. Okay, let's remind ourselves of what our CDF, capital F of x, is. Remember that we solved for this in question 1. And so all we need to do now is plug in our values where it has the x. So for instance, we're going to start with the probability that x is less than or equal to 3. We simply plug the 3 in where the x is. So it becomes 1 minus, because remember we have that 1 minus in front of the probability of x less than or equal to 3. It becomes 1 minus the CDF in green with our number plugged in where the x is. The next one, we want to plug the 4 in for where the x is. And similarly, we plug the 3.5 in for where the x is. See that once we have this CDF figured out, all we're doing is plugging in parts, and then of course we're going to have to solve. So, continuing on, it's very simple to see that 1 minus 16 over 3 to the 4 is just 16 over 3 to the 4. Similar for probability that x is less than or equal to 4. And same for the last one. So now we've got our 3 individual values. Remember that we said that we wanted to find these 3 individual probabilities and then multiply them together so that we can find the intersection of all 3 happening. So we'll simply plug those in. You see in the top left, I'm saying we want the probability, this is what we're asked for in the question, the probability that x1 is greater than or equal to 3, and x2 is greater than or equal to 4, and x3 is greater than or equal to 3.5, equals the sum, or equals the product of their individual probabilities. We've calculated those as the 3 numbers we have here, and we simply multiply them together to get our final answer of 0.001316. So pretty straightforward this week. Hope to see you all in tutorials, and thanks so much for listening. Talk to you later.